Welcome to Talking Machines by Sue Park, the podcast, where we talk machines, the bots, and the hottest AI papers off the press to demystify the world of artificial intelligence research. I'm Vic, and with me today is my lovely co-host, Alex.
Hey Vic. How you've been, girly?
Oh geez, I'm still recovering from the finale episode of Severance Season 2. Oh, and also that White Lotus episode.
Oh, for sure, that was an insane episode. We could chat TV for days, but let's dive into some fascinating AI research for a bit.
Let's get on with it then. Today, we're looking at a really interesting paper titled AgentRxiv, Towards Collaborative Autonomous Research. Now, that title might sound a bit technical, but the core idea is actually quite intuitive. Imagine if every scientist in the world worked completely alone, never sharing their notes or discoveries. Progress would be pretty slow, right?
Exactly, and that's the problem this paper addresses in the world of AI agents that are designed to do research on their own. Think of these as digital scientists. Up until now, many of these AI research agents have been working in silos, meaning they conduct experiments and write papers independently without really learning from what others have done.
So, the researchers behind AgentRxiv, Samuel Schmidgall and Michael Moor, asked a crucial question. What if we created a way for these AI research agents to collaborate, share their findings, and build upon each other's work, just like human scientists do?
And their answer is AgentRxiv. They've built a system that acts like a central online library, specifically for AI research papers written by these autonomous agents. They even modeled it after existing platforms like Archive, bioRxiv, and medRxiv, where human scientists share their early research findings. You can think of agentarchive.github.io as the digital address for this library.
So, an AI research lab, which is essentially a setup of these research agents, can upload its papers to this AgentRxiv server. Once a paper is up, other AI research labs can find it, read it, and use those insights to guide their own research. This allows for a cumulative building of knowledge over time.
It's like one AI lab discovers a new technique for solving math problems, uploads a paper about it, and then another AI lab working on a different kind of problem can find that paper and potentially adapt that solution to their own area. This transfer of knowledge between different areas is a huge deal.
To see if this idea actually works, the researchers conducted some pretty cool experiments. They tasked AI agent labs with improving their ability to solve complex math problems from a dataset called Math 500.
And what they found was fascinating. AI agents that had access to their own past research through AgentRxiv showed a significant improvement in their problem-solving abilities compared to agents working in isolation. They even saw an 11.4% relative improvement on average. It's like they were learning from their own mistakes and successes over time.
But it gets even better. The researchers also discovered that the reasoning techniques developed by these AI agents on the Math 500 benchmark could also be applied to completely different kinds of problems, like answering graduate-level questions in biology, physics, and chemistry in GPQA, reasoning-focused questions across various subjects in MMLU Pro, and even medical licensing exam questions in MedQA.
That's like a student who gets really good at algebra suddenly finding those skills helpful in their physics class. It shows that the learning really isn't just specific to one task. The best performing technique they discovered, called simultaneous divergence averaging, showed an average performance increase of 3.3% across these diverse benchmarks and even worked well with different underlying AI models. The details of how SDA works are in the appendix of the paper, but essentially, it involves the AI generating multiple ways to solve a problem and then checking if those approaches agree to increase confidence in the answer.
They didn't stop there. The researchers also explored what happens when multiple AI agent labs work in parallel, all sharing their findings through AgentRxiv.
Think of it as having multiple teams of scientists all working on the same big problem but able to instantly see what the other teams are discovering. The results showed that this parallel approach significantly sped up the rate of progress. They achieved higher accuracy on the Math 500 benchmark much faster when multiple labs were collaborating compared to a single lab working alone.
However, they also noted a trade-off. While the parallel approach was faster in terms of real-world time, it did use more computational resources because sometimes different labs might end up exploring similar ideas at the same time. It's like if 3 research teams all independently decided to test the same basic hypothesis before seeing each other's results, so there was some redundant effort.
The researchers also touched upon a really important aspect. Are the discoveries made by these collaborative AI agents actually new and novel? They used plagiarism detection tools and manual inspection, and while they found no direct plagiarism, they noted that some of the higher performing techniques were often improvements or combinations of existing ideas, rather than completely revolutionary new concepts. This is a really active area of research in AI right now, figuring out how to truly measure and encourage novelty.
Of course, no research is without its limitations. The paper highlights some key challenges they faced, such as AI agents sometimes hallucinating results, meaning they report findings that don't actually match their experiments. They also encountered issues with the AI agents proposing plans that were impossible to execute and difficulties in writing perfectly formatted research papers. These are ongoing challenges in the field of autonomous AI research.
And finally, the paper raises some really important ethical considerations. As AI plays a bigger role in research, we need to think about things like potential biases in the AI's learning, the spread of misinformation if the AI makes errors, and who is accountable for the research produced. The current guidelines, for example, state that AI systems can be credited as authors on research papers.
Overall, AgentRxiv presents a really exciting step forward in how we think about AI and scientific discovery. By creating a platform for collaboration, these researchers have shown that autonomous AI agents can learn from each other, improve their abilities, and potentially accelerate the pace of research.
It's like giving these digital scientists the opportunity to have conversations, share ideas, and collectively push the boundaries of knowledge. While there are still challenges to overcome, the potential for AI to assist and collaborate in scientific research seems brighter than ever, thanks to platforms like AgentRxiv.
Absolutely. This research really highlights the potential for autonomous agents to play a role in designing future AI systems alongside humans. It's a fascinating area, and we'll be sure to keep an eye on how it develops.
Thanks for joining us on Talking Machines today. We hope you enjoyed learning about AgentRxiv. Our goal is not to bore you, but fill you in on what's happening in the sci-fi slowly becoming our reality era we're living in. And today we learned about the ongoing research to assist or replace even the AI researchers.
Until next time, you can find us on Instagram at talking_machines_podcast.